Do the geese have language? We see a lot of animals that communicate pretty well. An intelligent dog can stay, go away, fetch the ball frisbee stick, tennis ball. An intelligent dog might have a listening vocabulary of a few hundred words. Does the dog have language? It's certainly communicating. If you tell it to fetch or stay, and when it's a fetch the tennis ball frisbee stick, non-tennis ball, and it consistently brings back the right thing. If we keep doing that over and over again, it would be very statistically unlikely that the dog keeps getting it right just by chance. Maybe a couple times by chance, but every single time, 20 or 30 times in, probably not chance. So there is human to dog communication. Does that mean that the dog understands English or Chinese? Does it have language? Do dogs have their own language? That's a pretty serious question. People research it a lot. We're pretty sure that the answer is no. Not real language. And this isn't to disparage animal intelligence. Yeah, some animals are dumb. But I don't mean to put an upper limit on animal intelligence here. Like, the example of Clever Hans is illustrative. Clever Hans was some horse in, I think, Germany 100 years ago, and they thought it could do arithmetic. They thought that because I guess they were bored one day, and they would show it some math problems, a plus b equals question mark. And obviously the horse can't really vocalize all that well. It can't really articulate numbers verbally. So to show an answer, it would just tap its front foot a number of times. Number of taps equals the answer to the arithmetic question. And the horse was getting pretty good at arithmetic, and so it got some attention, and some real scientists tried to do more controlled experiments. And upon doing better controlled experiments, they found that the horse wasn't really reading numbers and doing arithmetic. Like, if they hid some things but still showed the math problem, the horse would do nothing. And generally, this is presented as a failure of animal intelligence. But obviously the horse was doing something to get the problem right any of the time, and even attract that attention. So what was the horse doing? Well, generally, except in the later, very controlled experiments, the horse would get a person with a math problem written here. The person knows what the answer is. And the horse is tapping its hoof. And so as the horse keeps tapping, he's getting closer and closer to the right answer. But don't go over, that's bad. So as the horse starts tapping, the person's like, oh, he's getting close, he's getting close. Will he stop? Will he stop? Will he go over? And the person's getting excited, a little nervous. And so the horse got really good at reading people's faces and nonverbal cues. And the horse would just tap its foot until the person got to the right emotional state of, this is the right answer! You got it, stop! The person wouldn't say that, but they might be thinking it, and the horse was, if not good at reading minds, could at least read faces. And then people were like, the horse can't do math. But how important is that face reading skill? Like, if you did that test with me and said, there is a math problem. A plus B equals, what's the number? Yeah, I could answer it. I could do the math probably fairly well. But what if you hid the sheet of paper and I can't read what it says? I'd have no ability to guess the right answer, even if you gave me a tapping way instead of just calling out the right number. Whereas with the horse, you wouldn't even have to have the math problem in his field of vision. It could be off the screen, and as long as the human knows what it is, the horse can get the right answer because it can read faces just that well. That requires a lot of intelligence. If the horse had thumbs to play poker, that horse would be a world champion poker player. There's a lot of intelligence there. So whether it's the dog that can fetch a few hundred different objects correctly, or the horse that can read faces a lot better than most people can, there's room for considerable animal intelligence in the general broad idea of intelligence. But we're concerned with language specifically. Language is generally either written or spoken. And even smart animals have mechanical problems with these. Horses don't really have fingers. And if you try to look at the sounds that a horse or a dog make, they can only make, I don't know, maybe 10 different sounds. Whereas humans have a more variable vocal apparatus. Look at all the initials, all the finals, all the tones, all the consonants, all the vowels. We can make a lot of combinations of those. So the number of syllables that a dog can produce is like 1/100th, 1/1000th, or well, okay, probably about a 1/100th. The number of different syllables that a human can produce. They're just bad at vocalizing, and there aren't many animals that can hold a pencil. Like monkeys and raccoons, probably. Maybe a few others. So early on, people would try to teach animals to speak. But obviously, except for parrots, it doesn't really get anywhere. Parrots are good at vocalizing. Okay, so we have parrots. But everything else, it just can't really speak. Monkeys, though, they're pretty good with their hands. So people tend to teach monkeys human sign language. Doesn't matter if your voice doesn't work. It's just all hands. And monkeys are pretty good with their hands. So people have done studies with monkeys and sign language, and then parrots using verbal language. Okay, well, what do these smart animals do? What do they say? Generally, we get convergent results, whether it's monkeys, dogs, parrots, whatever. Generally, they can build up a vocabulary of a few hundred words. Is that a lot? Is that not a lot? It might be enough for super basic communication. But where is it relative to the average human? Well, the English language has 500,000 words. A person who's literate in Chinese knows a couple thousand to maybe 5,000 or 6,000 characters. On average, no matter what language it is, we usually use a few thousand different words in a day. Maybe 10,000 words is a basic vocabulary. That's about 2 orders of magnitude, 100 times larger than what the smartest animals have for a vocabulary. Hundreds versus thousands, tens of thousands, 100,000? It's a big difference. So the vocabulary size is very different. Like, humans are making up new words all the time. We discover new things. We invent new things. Some languages, especially English, like to steal words from other languages. Whereas the lexical landscape of animals doesn't grow all that exponentially. They generally can communicate hungry, sleepy, ball. They can communicate their own states and refer to physical objects in their environment, refer to verbs that they can do. But this is like a few hundred words max. It's not like it just takes off and goes on forever. So one big difference between human language and animal communication is the openness of the lexicon. Animal dictionaries, a few hundred words. You could probably fit a smart animals dictionary on one page. Human dictionaries, open-ended. Closed lexicon versus open lexicon. So we're halfway there. When I defined real human language, maybe programming languages, maybe, it depends on the language, as an open-ended lexicon mapped onto a recursive grammar, we're halfway there. We know what an open-ended lexicon is. We make up new words a lot. The dictionary just keeps getting bigger and bigger and bigger. So now on to the other half. Recursive grammar. What's that? Well, the easiest way to approach that is sort of like we did with the open lexicon thing. Look at what it's not. Look at communication, probably in animals, that doesn't show a recursive grammar. What do parrots say? Want cracker. Okay, 2 words. What do monkeys say in sign language? Usually something like, I don't actually know sign language, give ball. You get a lot of 1 or 2 word responses out of these animals. 3 words and we're like frying our brains. A lot of 1 or 2 word responses. Usually just a noun verb pair. Or just 1 noun, 1 verb. Hopefully you really know what's going on in the conversation so that you can fill in all the other relevant parts. Who should give the ball? Who should do what with the ball? Ball. Meaning, I would like that you would give me the ball. But the I want that you give to me the ball. Everything except ball usually ends up omitted from the sentence. Putting all those other parts in to the actual signed or spoken sentence would require some more grammar. animal sentences tend to be really short. 2 words, 1 word, technically not a sentence. And you don't really see much long stuff. Whereas yesterday we looked at Thomas Jefferson's first sentence in the Declaration of Independence, and I think it's like 77 words long. It's a long sentence. 2 words, 77 words. There's a bit of a difference here. What is that difference? It's recursive grammar. Animals, we've never seen one that really has it. And pretty much all human languages have recursion. There are these one people in the Amazon, the Paraha. It's almost like piranha, except if you replace the N with an H. There's this like one tribe that somewhere out in the Amazon that one missionary linguist found a few decades ago, and as far as we can tell, they do not have recursion in their language, which just messes up a lot of categories. It's a very interesting thing for linguistics, but it complicates things, so we're just gonna ignore that one tribe, and knowing that I'm technically factually wrong, say that human language always has recursive grammar. Except for those guys. But the rest of us, it has recursive grammar, which functionally that means that sentences can be as long as we want. Like with Thomas Jefferson's 77-word one. Okay, so now we have to define recursion. Next video, we'll give you a little break until then.